now we have an idea of how we're going to take a word like don't, or for instance, worry, with has a comma on there, and we're going to get rid of anything that's not a character. Okay, so given something like don't, how do we turn each character into some sort of a number? And for that, we're going to use this built-in function inside Python called ord. And so if I say ord of the letter D, it's going to return a number, and I can verify the type of that. It's an integer that we're getting back. So D is 68, and if we go back and look at that ASCII table again, where is that D coming for, that value 68? It's coming right here from its position as the 68th character in this table, and this is a very old table that is from really the earliest days of computing, when we decided that it was decided that these would be the characters basically that existed on a teletype that needed to be represented inside the computer. The first bits here, you notice, up through 31, I put NA here because they're really unprintable characters, all versions of a manner of white space and control characters, and so we can't really print those. But starting at 32, that's a space, and then we have all these bits of punctuation, and so they are represented when you type a comma, for instance. The computer is going to represent it as the character 44. So the ord function allows us to go from any one of these characters to its ordinal value in this table, and we can go reverse with the char function. So if I say char of 68, it's going to tell me that character is D. So it's just reversing that. And here I show that ASCII table. So how can I get each one of the characters' numeric value? Well, I could use a for loop, right? So if I say the word is equal to don't, I could say for char in word, and that's going to allow me to iterate over each character in the word. And I can say print the char and also the ordinal value of the char. And it's going to show me, oh, actually I used I included the apostrophe there. I will not be using the apostrophe, but it does show me that 68, 111, 110, 39, it does have a value. You don't have to remove it, but part of the exercise is just to play with regular expressions. So we are going to use this. We are going to use the removing the punctuation, but if you were writing your own version of this, maybe you want to leave the punctuation. That's totally fine. So 68, 111, 110, 116, that matches what we see over here. I do want to point out that the letter uppercase D and lowercase d are two completely different characters. They are represented as two different places in the table, and this is actually why the uppercase D resorts before the lowercase d. It's because it has a lower value in the ordinal value. So one of the things I really want to point out here is that we can actually iterate over the values from A to Z by using this range, but the range function. So we can actually, if I run this code here, take this, pop it in here, I can use, so the range function, so the ordinal value of A, the letter A, is 97, and then the ordinal value of Z is 122. And of course, the upper end of range is not included, so we have to go one greater than that. So if we say that plus 1, we're saying what is the range from 97 to 123. That I have to say list, because that's a lazy function. So that's going to return each one of the numbers between 97 and 122, and I can iterate over those and say, what is the character for those. So char in for in range, and if I wanted, I could say 97 to 123 is the same thing. So that's just a way of understanding that these letters lie contiguously in this table. So I can go from 97 to 122 and turn those into the characters A to Z. And that's how we can say, like numerically, we can say F comes before J because it has a lower ordinal value. We just turn those characters into numbers. I don't know. To me, when I kind of realized this, it was like kind of revelationary, and so I thought it was really cool. So it's just really important to understand that the letters A to Z lie contiguously in the ASCII table, as do the letters A to uppercase A to Z. So let's go back and just look at that table. Uppercase A to Z, those all lie one after another. And then there's a gap between the uppercase Z and the lowercase a. There's some other characters in between. So if you were to try to create a character class, for instance, uppercase A to lowercase z, you would be including these other characters in the middle, which is why we don't do that. So, and it's also why you can't say find all and lowercase a to z, because it's going to take this lowercase a and then try to, which has a value of 97, and go to z, uppercase Z, which is 90. It would be 97 to 90, and that doesn't work. Those don't lie contiguously from low to high, and so that would actually blow up if we take that code and go over here. And what is word? Oh, word should be equal to oops. Let me clear that. To don't without that. And if I were to say find all lowercase a to uppercase z in Word, it's actually going to create all of this errors. It created this, it's this exception. And the last thing I see here is bad character range A to Z at position 1. And the reason why it's a bad character range is because we're trying to go from 97 to 90, which doesn't work. That's not the way the range wants to work. So I think that once you understand the ASCII table, it helps you understand how you write these regular expressions a lot better. We could reverse that and go uppercase a to lowercase z. So uppercase a 65 to lowercase z 122. And if we run that, let me clear that and go uppercase a to lowercase z, it finds all the letters. But the problem is that this range also includes these characters in between. And if we actually really only want the letters, we need to be more specific about that range. So here I'm just proving the point that there's a bunch of things in between Z and A that we don't want them. And here I'm proving that if I use this pattern on all the printable characters, so this is actually kind of interesting to me. If we import the string module and then we look at string printable, these are everything that can be printed to the screen, and if we try to use this character range on all the printable characters, you notice it's going to find a bunch of things that we actually don't want for this specific program. We don't want these bits. We only want the letters and numbers. So that's why we say specifically A to Z capital, A to Z lowercase, and then 0 to 9. Those are the only characters we want, and the reason why we can use these ranges is because those characters lie contiguously in the ASCII table. And so we're very specific about A to Z, because we know that there are other characters in the middle. So very kind of laborious explanation of that, but hopefully you really understand it now while we write this character range. And you'll see this quite a bit, or at least if you're looking at my code, I use this quite a bit. A lot of times when I'm cleaning up, for instance, the headers in a CSV file, it's so common for people to put in spaces and punctuation and underscores and dashes and stuff, and I don't want any of that in my headers, column headers in a CSV file. So oftentimes I'll sanitize those headers by removing anything that's not in this character range, and then probably also lowercasing it just to make it easier for me. So I use this regular expression all the time, and I think it's really worth understanding how it works.